Hello class, I'm working out of Algebra 2, 2.3, writing linear functions. We'll be working with examples 1 and 3 on pages 69 and 70. Before we begin, let's look over our slope-intercept form y equals mx plus b and its parts. We know x and y, that's the ordered pair that we're given, x comma y. Slope has lots of names. Let's get used to using m for slope, as we see in the formula right here. But also, what does it mean? It means rise over run, the change in x over the change in y, and this idea, which we will be using. When you're given two ordered pairs, there's two y's and two x's. So y subscript 2 minus y subscript 1 in the numerator over x subscript 2 minus x subscript 1 in the denominator from the two ordered pair points that you're given. In this part, B is the y-intercept. That means when you graph on the Cartesian plane, this point B will intercept the y-axis wherever B sits. That's where it crosses the y-axis for your graph. So there's a lot of information in the slope-intercept form. It'd be cool to jot these down on index cards and remember all this information to help you. Alright, so for different problems, you're going to be given most of the information and you need to solve for the parts you're not given. In the first example, 1, you're asked to write a linear function modeling the line passing through 2, 1 with a slope of 2, 3. We're going to use y equals mx plus b. We have an x, 2. We have a y, 1. And we have a slope, 2/3. We're given most of the information for the slope-intercept form, so look for that. What do we need to solve for? The b, which is the y-intercept. When we graph it, that would cross the y-axis at that point where x is 0 and b would have a value. Let's solve for b by plugging or substituting in points. Alright, so we have 1 for y equals 2 over 3 for slope times 2 for x plus b. Now we can solve algebraically for b. So we have 1 equals 2 times 2 is 4 over 3 plus b. Let's do some work in the margin. 1 equals 3 over 3. And we want to use that because it's the easiest denominator to rename 1 for in the purpose of this problem. So we're going to make 1 as 3 over 3 based on this idea in our margin. How does that help us? Well, now we can isolate b on the other side of the equal sign. We're going to do that. We're going to have 3 over 3 minus 4/3 equals 4/3 minus 4/3 plus b. So we subtracted 4/3 on both sides of the equal sign to get b by itself algebraically. We've done that a lot, so I'm kind of moving through it. This goes away. Now we have 3 minus 4 over the same denominator 3. That would be a negative 1/3. equals b. I'm going to go to a new slide, so look that over. Negative 1/3 equals b. That is our y-intercept. So now whatever our x's and y's are, we can choose any plotted point, and we have a lot of information in the slope-intercept form from the original problem to graph. So negative 1/3 is our y-intercept. It would fall somewhere like right here on the graph. And since slope is rise over run, we can actually plot our line without an x and y point, in addition to having an x and y point. Either way, we'll see what emerges. We'll do that real quick. So a rise of 2, a run of 3 from our y-intercept. So 1, 2 for the rise, 1, 2, 3 for the run, and we would actually plot our point on the graph right about here. We rise and run from that negative 1/3 at the y-intercept. It's as easy as that. A line starts to emerge, and like we talked about in class, it's a positive slope, which we see 2/3 is positive as well. All right, so when we rename y as a function of x on this problem, the function of x is y equals 2/3 x minus 1/3, to write it as a function. The function of x, you would plug the x in and substitute the x in your ordered pair to find the y, if you're not given that. And since the function of x is equal to the y, you would have an x and y as well if you had to go the other direction and decide what your ordered pairs are. All right, we're going to go over example 3. Write the slope-intercept form. Okay, well, that's y equals mx plus b. That's what we're working back to, slope-intercept form. Of the equation passing through these 2 points, negative 4, 3, and 2, 6. So we're given 2 points, and we're going to use the slope formula that we talked about earlier to do this. So if m equals the slope formula, we have an x and a y. In our first plotted point, we have an x and a y. In our second plotted point, we can label them x1 and x2, y1 and y2 between the first and second points, and use that to find slope. Let's do that. The y2 minus the y1, 6 minus 3 on top. The x2 minus the x1 is 2 minus a negative 4 on the bottom. Okay, 6 minus 3 is 3. Remember 2 minus a negative 4, we can make that a positive to help us. And that is over 6. Always simplify 1/2. Now we have a lot of information. We have the choice of 2 points on our graph. We solved for slope, and now we're going to solve for the y-intercept in our slope-intercept form. We pick a point to do that. We're going to just pick 2, 6. And we know slope is 1/2 from solving for that. So we have a point 2, 6. Slope is 1/2. And we're going to think about our y first. 6 equals 1 over 2 times our x, 2 plus b. Let's solve for the y-intercept in slope-intercept form. In the margin right away, 1/2 times 2. We can put that over 1 to make it look like a fraction. This cross cancels, and we have 1 to rename that whole part of our problem. So it'd be 6 equals 1 plus b. We can subtract 1 from both sides, and we're going to get 6 minus 1 is 5 equals, this goes away, b. Okay, whatever your plotted point is, you can choose from any plotted point to use in slope-intercept form. We've solved for b, and we have slope at 1/2. So you're asked for the slope-intercept form of the equation passing through a couple of points. Using one of those points to solve, we get y equals 1/2 x plus 5, because our b is 5. Now we can use any ordered pair x or y to help us graph on the Cartesian plane by solving for slope-intercept form. We also know that on the plane, our y-intercept would happen at 0, 5, because if we plug 0 in for x here, y equals 5. So we have another plotted point just from the slope-intercept form. Pretty cool. Then we can plug in any plotted point, x and y, from this form and graph. Also, we can basically use our intercept of y at 5, 0, 5, and we can rise 1, run 2, and plot our points from that information as well. So there's a ton of information in the slope-intercept form, y equals mx plus b. Will we need it again? That would be a true statement. So pop that down on index cards, look at the parts, understand how it is used. I'll see you soon.